Hi, I'm the Rick and Rick Turns, and this is the 5th video in my series of videos about making this tool rest. Today I'm going to be machining the parts, which really just involves cutting them to length with an angle grinder and a cutting blade, and drilling a few holes in the arm piece right here, drilling a hole in the post, and tapping the hole in the post. Before we get started today, let me just mention, be safe, work safe. You're going to be creating a great deal of sparks when you're cutting metal if you're using an angle grinder. When you start doing the brazing, you're going to have an open flame. The metal parts you're working on are going to be extremely hot. So be careful, be safe. Try and work in an area that's got no debris on the floor at all. I've got a machinist vise mounted on a chunk of log so that I can roll it around. I roll it into the middle of my garage when there's no cars there. And I've got 5, maybe 8 feet of clear space all around my work area. So when I cut it, all those sparks are just going to hit the concrete. If you can work outside, that's good too. Just remember, the metal parts are hot. Don't touch them. Don't accidentally pick them up. You might want to stick a pair of pliers right near your vise where you're holding the work to remind you that if you pick the thing up, use the pliers initially until you're sure it's really cooled off. Finally, those cut metal edges are going to be really, really sharp. So be careful around them until you go through and ease them with angle grinder and an abrasive disc or a file or something else. So let's get started. Got my tool post marked here according to the method that I showed you in the last video by putting it in the banjo on the lathe. This is the actual length, so I'm going to mark my cutting length here about a 1/2 inch long. So even though I've done this a number of times, I don't want to accidentally screw it up. And now what I suggest you do is mark it all the way around. You can do this on your lathe just by clamping it up and chuck if you've got one, or you can do it like this or whatever it takes. That's pretty good. Reason for doing this is just to help come up with a straighter cut, because the cut that we need right across the top surface, this surface right here, needs to be absolutely perpendicular to the length here. If it's not, what will happen is that when you mount the arm on it, it's going to be crooked. It's going to go down to the right, it's going to go down to the left, or possibly it'll go tilt towards the front or towards the back. Now, front or back is not a problem really, but tilting towards the left or right can be quite annoying when you spend a lot of time working on it. After we cut this with the angle grinder, I'll show you how I attempt to ensure that I've got a perpendicular surface here. But the first thing to do is try and get the best cut you can right here, so that whatever you do to it to straighten it up, you won't have to do too much work. This is a piece of 2x3 angle iron that I'm going to be making the arm out of. And for this particular tool post, I'm going to make this 11 inches right there. Now I suggest that you make a long mark all the way around the 2 outsides of this, rather than trusting that when you've got your angle grinder going, you're going to get a straight cut. And a crooked cut doesn't really matter that much. It's just ugly and unprofessional looking. So make the mark all the way around, just like that. Now it'll be easier to get a nice straight cut when we start cutting with the angle grinder and the cutting wheel. Well, this is my portable machinist vise that I move around when I'm doing the little bit of metalworking that I ever do, which is really just making tool rest. I've got my angle grinder right here. So you can see I've got a cutting wheel in it. So this is my tool post piece. This is the good end that will be brazed onto the tool rest arm. And I'm going to make that cut right there. That's the one I just marked. Just an additional note here. The guard here will catch some sparks. You want to keep it angled down like this, so hopefully it'll keep most of the sparks off of your legs and your feet. You don't need to apply much pressure. The weight of the tool is plenty for making the cut. When you're making this cut, you don't want to twist the tool like this. That would probably end up breaking the blade, this blade. So try and keep it straight and not rubbing on the sides. All right, that cut is done. I'm going to get a pair of pliers to pick up that piece of rod there that I just cut off. Okay, we got half the cut made. So I'm going to reposition it here. And ready for that cut right there. This is my 5/16 inch steel rod. This is going to be the wear strip. I've marked it the exact length of the arm, and I'm going to cut it right here on the outside of the mark line. All right, there we go. I put a grinding polishing wheel, a flat disc, in my angle grinder now, and I'm just going to ease the edges. Those cut edges are really quite sharp. This is the cut surface right here, and I'm just going to ease the edges a bit. Now here's the piece of tool post that I cut just now. This is the cut in that I just did, and I'm going to check this for square. Just using a regular square is fine. And as I suspected, it's not perfectly square. It's pretty good, but it's just not quite there. Now, as I pointed out before, this surface really needs to be perpendicular to the length here. That will ensure your tool post is sitting all the way straight across, and you definitely want that. And the way I'm going to do this is by putting it on my... I'm going to pin, this is a metal lathe. I got my chuck with a small pair of jaws in it, and I put this in here. Oh, about 1.5 inches in, I think, and tighten it down. Okay, it's as tight as I can get as well. What I'm going to do here is turn it with a carbide bit. Carbide bit tool. And this is a carbide bit, appropriately enough. And I found This will cut steel pretty well. Doesn't cut it tremendously fast. It will cut it. Blacken this completely so that as I cut, I can see the parts that have not been touched. All right. If you don't have a carbide tool, I would suggest you try this anyway, but use a file. A file is not great. It's not going to cut as fast as a carbide tool is, but it'll probably do pretty good for you. All right. I've got my lathe set at 600 RPM. I don't know if fast or slow is good. I generally do it slow, just on the theory that maybe that's a little safer. So I'm going to be making a shear cut, sort of from the middle in. This particular carbide blade has got a very slight radius on it, so it's not going to hit all the way across, and really that's what I want. I think you can probably see I'm getting some very, very fine shavings there. And after only that, I apparently cut it fairly well. We still have a little bit of black in here, so I need to keep turning it, and a little bit in the center there, but I'll clean that up when I'm done. Now, one thing you can manage to do is dish the surface a little bit this way, so I have to be careful with that. Another thing is, don't wipe the debris off with your finger. These little shavings are really, really sharp, and they will get in your finger immediately. All right, let's keep going. Another thing I'm going to do here while I've got this here, I'm going to use the very edge, the very point right there, and put a little dimple right in the center, because I'll be drilling a hole there. Okay, I think I'm getting there. Still got a little bit of a depression in there from where I didn't hold the tool very well. Unfortunately, I cannot put the square on there. It's too big. But I can check to see that I don't have it dimpled in the center, or raised in the center, that is. And that looks pretty good. So I'm going to keep turning this down till I get a nice, even surface. One thing about brazing, you got to have a good surface between the two pieces of metal. And this hopefully will ensure it. If you don't have a chuck that you can chuck up your metal in like this, you could put a chunk of wood on a faceplate, drill a 1-inch hole in it, and mount it like that. That might be more trouble than it's worth. Or you could just clamp this in a vise and use your file on it to clean up the surface and get it as flat as you can. Okay, I think that's good enough. One problem you might want to run into is if your banjo opening is a tiny bit less than the stated amount. Say it's a couple of hundredths less than 1 inch. Or in the case that I ran to, we were working on a 7/8 inch banjo post, and well, the banjo opening was a little bit less than that. So the same technique of cutting here will allow you to cut here. It's a little bit more difficult because you've got a longer length. You're going to want to cut up at least 1.5 inches, maybe 2 inches. You do the same thing with your carbide tool right here. Or if you've got a file, do the same thing there. Might take a little bit longer. Now there's one other operation I want to do while I've still got the post mounted in the lathe. And that is to drill the hole right in the end of the post. It's the end that is dead flat or dead perpendicular to this, because this is where it's going to meet the arm, and that's where I want to have a tapped hole here and put a machine screw through the arm to hold the two together temporarily while I braze it. Now for this operation, I'm going to be using a centering drill like this and a Jacobs chuck here. Now if you don't have a Jacobs chuck for your lathe, then do it on the drill press, or if you don't have that, you can do it by hand. In either case, a centering bit like this is fairly inexpensive. Fairly inexpensive and does a really good job, because a regular drill bit will just kind of skate around. Now that is of course why I turned a little dimple right in the center there to help with that. Okay, so the centering bit is a very thick shaft and it doesn't flex when it drills. So it's really good for getting that little hole going in there. Okay, my lathe is set at 600, and now I'm going to drill that hole there. Just very gently. You can see the center bit also has a bevel right up here, and I'm going to allow it to cut a little bit of a bevel in there to make it easier to get the drill bit started for the hole that will be tapped. Now I'm going to remove the centering bit and put in the bit that will be used to drill for the tap. And that is this one right here. Now I'm not really sure exactly what size that is because I bought it as a set. It's a 1032 tap, and this is the bit that came in the blister pack with it. So I'm going to use it. I'm going to drill a hole that's about 1 inch deep. It's not really critical how deep I go with it. It just needs to be shorter than the bolt that I try and put in it. Maybe 1/8, maybe 3/16 inches shorter. Because the tap that I'm using is just a standard, it's called a plug tap. And the plug tap won't cut threads all the way to the bottom of a closed hole like that. So I want to make sure that I get the hole that goes in here maybe 1/4 inch longer than the bolt that I'm going to put through there. So what I have now is a hole that is dead center, goes down in here over 1 inch, and is completely parallel to the outside of this. This is ready to be tapped. Now if you don't have a Jacobs chuck for your lathe, and so that you can't drill the center hole on it, I would suggest doing it on a drill press, and that of course is assuming you have a drill press that you can work on. And this will work fine. Okay, the only slightly tricky thing about it is you've squared up one face right here, but this one may not be exactly perpendicular to the length. Matter of fact, just looking at it, I'm pretty sure it's not. So if I just drop it in here and clamp it up, it may not be true. What I need to do is this. Just make sure that when I clamp it up, it's going to be straight. It's going to be perpendicular to the table here, so that when I drill that hole, it will be perfectly parallel to the center line, right on the center line, up and down. And with this, I would also use the centering bit. And then after I've got that in place, take out the centering bit and put in the bit that's appropriate for the tap that I have, 1032 tap, and drill out the rest of the hole like that. I'm ready to tap this. What I have here is my 1032 tap. This type of tap is called a plug tap. There are other types of taps. I think one of them is called a bottoming tap. I'm not real sure. This is the only type I've ever really used. And it is made, of course, for tapping holes. It's really made in tapping all the way through a piece of metal. In this case, though, I'm going to tap down about 3/4 of an inch. Like I say, I drill this hole 1 inch deep so that I can tap less than that. Now to hold a tap, you've got to have a tap handle, which is what this is. The tap fits right in here, in the teeth of the tap. I don't know if that shows up real well, but once you have it in there, you just tighten it down. That's going to hold that tap real secure. There are other types of tap handles, of course. This one happens to be a ratcheting handle. So I'm going to put a little oil on here. That does help the tapping. I'm going to put the tap in there, try and hold it directly straight upright, and just very gently get it started. Now it is possible to get this thing going in crooked, and you definitely don't want to do that. You want to take it real slow, get it going like this. Now the threads on the tap are tapered to some extent so that you can actually do this, so that you can get it going in there without a great deal of hassle. And that makes it fairly easy to use. I turned it a number of times. I'm beginning to get some resistance now, so what I'm going to do is just back the tap out a little bit, and that breaks the chip that it's been cutting. So I backed it out, 1/4 of a turn, 1/2 a turn, pushed it back in, and now I'll take it in maybe another turn and back it out again. So until I get this down as far as I want it to go, I'll turn a 1/2 a turn or a turn and then back it out to break the chip. Makes it work much easier. Now, if you put too much pressure on this, you can break the tap. I used to use, or try to use, 832 taps, and it's just not strong enough for my clumsy attention. So I went to the 1032. The 10 is a thicker screw shaft. And I don't break as many taps that way. Okay, it's not going to go any further, so I've hit bottom. I'm going to pull it out now. I've got the arm, what will be the arm of the tool rest right here. Now this is going to be the part that projects upward. We'll have the wear strip along here. This is the part right here that's going to attach to the tool post. The tool post will be attached to it right down here. As I've been talking about, I want to drill a hole in here so I can put a bolt through it. I've got a 1032 bolt right here. And I've just selected a drill bit that's a little bit bigger than that because I don't want this to bind in the hole at all. And I don't want to tap this hole either. I want it to be loose. So this is, I think, a 7/32 tool bit. And I put a slight dimple here on the metal so that I can get it going easier rather than using a centering bit on this. All right, let's get started. I've got the drill set, I think, at its lowest speed. Put a little oil on that to make it cut cooler. All right, there we have it. Now there's 2 more holes that I need to cut in to the arm. And they're going to be on the top surface here, actually right down here. And the reason for these holes is only to run a piece of wire in there and hold the wear strip in place while I get it brazed. It'll be sitting in a machinist vise, of course, up like this. And I need something to hold that wear strip in place long enough for me to braze it. So that's what these holes are going to be, one on each side. And I will just take a short piece of wire and just kind of wire it in place. The placement of these holes is not really significant. Now let's get started. I haven't punched these or anything. See if I can get the hole going okay. Put a little drop of oil on it. My arm piece is almost ready. There's just one more operation. When you get it from the factory, piece of metal along here, it's going to be a little bit rounded. It's not going to be nice flat with sharp angles. It's just going to be rounded over, as you can see there. Now, the wear strip is going to be held on here with a couple of wires here and here, just loosely held in place, or as tightly as I can get it held in place. But in order to braze it, I want to flatten that round right along there. So what I'm going to do is just run it across here until I get that round removed and have a nice flat area. Okay, it probably doesn't show up real well in the video, but it is getting nice and flat there. And it doesn't really even have to be all the way across the width of this metal, although that would be nicer, but that's looking pretty good. Now, you don't have to do this with a bench grinder. You could do it with a file and it would work. It would just be slower. And that looks good. You got a nice flat area all along the length of it. We've got our metal cut to the right length. We've got holes drilled where appropriate. We've got our one hole in the tool post tapped. So, in the next video, going to put it all together. We're going to braze it all together. So, join me next time. We'll get it almost finished.